Here's a question that has a deeply uncomfortable answer. If you took a thermometer into deep space, what would it read? Most people say something like very cold or close to absolute zero. And they are right, but here is what nobody tells you. That thermometer would also be wrong, because temperature, by definition, cannot exist in empty space. It is physically impossible. Temperature is not a property of a place, it is a property of matter. And where there is no matter, the concept of temperature itself breaks down entirely, which raises an even stranger question. If space has no temperature, why do we keep saying it is cold? The answer requires you to unlearn something first. Temperature is not a sensation floating around in the air. It is a measurement of how fast particles are moving. A hot object is a collection of particles in violent, chaotic motion. A cold object has particles barely moving at all. And absolute zero, negative 459 degrees Fahrenheit, is the theoretical floor, the point at which particle motion drops to its absolute minimum. Nothing in the known universe has ever actually reached it. Here's the part that locks everything into place. If there are no particles, there is no temperature. A thermometer in a true vacuum has no surrounding particles to exchange energy with. It just sits there, radiating its own heat outward into emptiness, reading only itself. Deep space is not quite nothing, but it gets uncomfortably close. In the voids between star systems, there is roughly 1 atom per cubic meter, just one. On Earth, that same cubic meter of air contains around 25 quintillion molecules. The difference between those two numbers is almost incomprehensible. Space feels cold not because it has a cold temperature, but because it will drain the heat out of anything placed inside it, with almost nothing pushing back. To understand why, you need to know the 3 ways heat moves, because space eliminates 2 of them entirely. Conduction requires physical contact between particles. In space, objects are nowhere near each other, so conduction does not exist. Convection requires a fluid medium to carry heat through currents. Space is a vacuum, so convection is gone too. That leaves only radiation, electromagnetic waves that travel at the speed of light through a perfect vacuum. This is exactly how the sun's energy crosses 93 million miles to reach Earth. But here's the critical point almost everyone misses. Radiation does not heat the vacuum it travels through. It only transfers energy to objects it physically strikes. The sun pours energy outward in every direction, and virtually all of it passes through the vacuum without warming it, because there is almost nothing there to absorb it. Space is not cold because the sun is far away. Space is cold because space is empty. This is where intuition breaks down completely. If space is so cold, why do spacecraft need cooling systems? Why are spacesuit engineers just as worried about overheating as freezing? Because space gives you 2 savage extremes simultaneously, with nothing to soften the gap between them. On the sun-facing side of any object, temperatures can reach positive 250 degrees Fahrenheit. Rotate that same object a few feet into shadow, and it crashes to negative 250. No atmosphere exists to carry warmth around the edges. The moon makes this brutally clear. Standing in direct sunlight at the equator, the surface hits 250 degrees Fahrenheit. Step into the shadow of a crater and it drops to negative 290. 2 realities feet apart, divided by nothing but a line of shadow. The International Space Station experiences this every 90 minutes as it cycles in and out of Earth's shadow, its exterior swinging between both extremes with every single orbit. NASA's Parker Solar Probe is the most dramatic proof of all. In April 2021, it flew within 6.5 million miles of the sun's surface, deep inside the solar corona. Its heat shield faces temperatures around 2,500 degrees Fahrenheit, hot enough to melt steel. And yet, directly behind that shield, the spacecraft's instruments operate at negative 238 degrees Fahrenheit. The shield absorbs the radiation. The shadow behind it stays frozen. A few inches of difference between an inferno and a deep freeze. That is not engineering. That is physics being perfectly consistent. The vacuum is not hot. The surface radiation strikes is hot. Everything in shadow is not. Now the final layer. Space is not at absolute zero. It has a faint baseline temperature, and its origin is one of the most remarkable accidents in scientific history. In 1964, two astronomers in New Jersey kept detecting a persistent background noise in their antenna coming equally from every direction in the sky. After ruling out every explanation, including pigeons nesting in their equipment, they realized they had stumbled onto the afterglow of the Big Bang itself, the oldest light in the universe, still echoing 13.8 billion years later. That radiation, stretched and cooled by cosmic expansion, now fills every cubic centimeter of space at negative 455 degrees Fahrenheit, just 4.7 degrees above absolute zero, and it is still cooling. The universe today is colder than it has ever been at any point in its history. Tomorrow, it will be colder still. The coldest confirmed natural place ever measured is the Boomerang Nebula, 5,000 light-years away, where rapidly expanding gas has cooled to negative 457 degrees Fahrenheit, colder than the background temperature of space itself. Mercury pulls everything together perfectly. It is the closest planet to the Sun, yet at night it drops to negative 290 degrees, colder than Mars, which orbits 3 times farther away. No atmosphere means no heat retention. The moment the sun sets, warmth bleeds into the vacuum and the surface collapses. Venus does the opposite, farther from the sun than Mercury, yet its surface stays at 900 degrees Fahrenheit day and night because its thick carbon dioxide atmosphere traps everything. Distance is almost irrelevant. What controls temperature is whether anything is present to catch radiation and hold onto it.
So here is the complete picture. Space is cold because there is almost nothing in it to absorb heat. The sun's energy passes through the vacuum without warming it. The universe's baseline temperature sits just barely above the coldest point physics allows, and every warm thing in existence, every star, every atmosphere, every livable surface, is a small, isolated exception surrounded by an almost infinite cold. Earth is extraordinary not just because life exists here, but because this planet sits in a precise, narrow window. The right star, the right distance, the right atmosphere to catch radiation, spread it evenly, and hold on to it long enough for everything we know to exist. Remove that atmosphere and this planet becomes the moon. Lethal heat in sunlight, lethal cold in shadow. Nothing in between. The warmth you feel stepping outside on a clear day is not the natural state of the universe. It is a rare, protected exception in a cosmos that is almost everywhere and almost always completely and profoundly cold. So the real question was never why space is cold when the stars burn so hot. The real question is how, in a universe that empty and that cold, something as fragile as warmth ever managed to survive at all. If that shifted something in how you see things, there is one more layer waiting. Our entire solar system is sitting inside a massive cavity carved by ancient supernova explosions, and most people have never heard of it. Watch the next video to find out what is actually surrounding us right now.